Day 500 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we made it to day 500 where we've been doing daily LeetCode problems for 500 days in a row. So if you've been following along this channel the whole time, make sure you give yourself a pat on the back for staying disciplined and staying consistent. Now today we have question number 1935, maximum number of words you can type. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. There's a malfunctioning keyboard where some letters do not work. All other keys on the keyboard work properly. Given a string text of words separated by a single space, no leading or trailing spaces, and a string broken letters of all distinct letters keys that are broken, return the number of words and text you can fully type using this keyboard. All right, y'all, so that sounds a little bit confusing at first. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input text equals a string hello world. The broken letters are A, D. The output is 1. Explanation says we cannot type world because the letter D key is broken. So let's break this down one step further, y'all. So they give us a input string text, which is hello world in this case, and they give us another string of broken letters, which in this case is AD. So in this case, the A key on the keyboard is broke, and the D key on the keyboard is broke. That's what this broken letters mean, right? So we need to see how many words in this text string that we will not be able to spell because of these broken words. So in this case, we cannot spell word, or excuse me, we cannot spell world because D is broke, meaning there's only one word that we will be able to fully type using the keyboard. So excuse me, we want to return the number of words that we can fully type. So in this case, we can fully type hello, and that's only one word. So the output is 1 because there's only one word that we will be able to fully type, right? It says return the number of words in text you can fully type using the keyboard. So in this case, we can only type hello because we cannot type world because the D is broken, right? It tells us right here that the D is broken, so we cannot type world. We can only type hello. That's hello is only one word, so our output is 1. So just in case that didn't make sense, let's take a look at example 2. In example 2, we have our input text equals a string leet and then code, 2 different words. LeetCode is 2 different words in this case. And then broken letters equals L and T, a string L and T. This time the output is still 1. Explanation says we cannot type leet because the L and T keys are broken. So once again, these 2 keys, the L key is broken on the keyboard and the T key is broken on the keyboard. So since the L and the T keys are broken on the keyboard, that means we cannot type this word leet, right? But we can still type this word code. And once again, we want to return the number of words that we can fully type using this keyboard. We can fully type code. That's only one word that we're able to fully type out of this string. So our output is 1. Now let's take a look at example 2 where we cannot type any of the words. So in example 2, we have our input text equals the string leet and code. Once again, 2 different words. Broken letters equals a string E. Our output is 0. Explanation says we cannot type either word because the E key is broken. So since both of these words contain the letter E, we cannot type either one of them because remember, we need to type that we need to count the words that we can fully type. We cannot fully type either one of these words, right? So the output is 0 because the E key is broke. So, and both of these words have E's. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, actual solution. Solution is not that difficult at all. So let's get into it. Now, the first thing we are going to do is we are going to convert the broken letters into a set, which will help for big O1 lookups. So we're just going to say let broken equal a set, open up the parentheses, and we're just going to pass in broken letters from up here. Boom. That's where this broken letters comes from. Boom. So we're going to pass in broken letters. Boom. Now we need a counter for words that can be typed. So we need to be able to count our fully created words, or the words that we can fully type. So we're just going to declare a variable called count and set that equal to 0. Boom. Now we need to split the input text into words separated by spaces. So we are going to say for w in text dot split, open up the parentheses, separator colon, and put in quotation marks and put a space in those quotation marks. That's going to be our space, and that's how we are going to separate each word. That's hence this word separator. So we're going to separate each word with this blank string, or excuse me, we are going to know that we're at a different word. That may sound a little bit confusing. So this is just going to let us know that we're at a different word, because remember, this is all in one string. So we need to let the compiler know when we're going from this word to this word. So what this is doing is every time the compiler sees this blank or this space string right here, or this space, then it knows that we're in a new word. Boom. Then, so let's open up the brackets. Then we're going to assume the current word is typable until it's proven otherwise. So we could just declare a variable called OK, and we're going to set that equal to true to start. Then we're going to check each character in the current word. So we're going to say for CHNW, we're going to open up the brackets. And if the word contains a broken letter, we're going to mark it as not typable and stop checking. So we're going to say if broken dot contains, open up the parentheses, CH, then we're going to open up the brackets, and we can just say OK equals false. Then we could break after that. We'll say semicolon break. Boom. Now, if the word had no broken letters, then we can increment the result counter. So we can increment this counter right here. We come right here underneath this for loop. So we'll say if OK, open up the brackets, and we're going to say count plus equals 1. Boom. Now we need to return the total number of words that can be typed by coming right here. And all we have to do is say return count. And that's it, y'all. That's all she wrote, y'all. Let's give it a run. Make sure it runs correctly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. Ooh, 2 milliseconds beats 60% of users. We could get those numbers up, y'all, but right now we just want to be able to have the skills to solve the problem that is presented to us. I feel like this is a good solution for that. It's easy to understand. It's a solution we can all learn from pretty simply. So that's why I like this solution. Now, with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.